Good morning, teachers and fellow Assumptionites. My name is Kylie, and here with me is Veronica, and we are both from Class 2G. Today, we'll be presenting to you our presentation on earthquake-proof buildings.
What is an earthquake? An earthquake is an intense shaking of the Earth's surface. Movements in Earth's outermost layer cause the shaking. What are the impacts that earthquakes have on structures?
Earthquakes send shockwaves throughout the ground in short and rapid intervals that extend in all directions. Buildings are generally equipped to handle vertical forces from their weight and gravity, but they cannot traditionally handle side-to-side forces emitted by quakes. This horizontal movement vibrates walls, floors, columns, beams, and the braces that hold buildings together. The difference in movement between the bottom and top of buildings exerts extreme stress, causing the support frame to rupture and the structure to collapse eventually.
Engineers plan to make earthquake-resistant buildings with this information, but how would they do that? Engineers work to reinforce the structure and counteract a potential earthquake's force. Since earthquakes release energy that pushes on buildings from one direction, the strategy involves having the building push towards the opposite way. 3 ways they do that is to counter the forces with damping, shield the buildings from vibrations, and reinforce the building structure.
How do engineers carry out these processes? First of all, when countering the forces with damping, one way is to use pendulum power. When the building begins to sway, the ball acts as a pendulum and moves in the opposite direction to stabilize the building.
Next, to shield the buildings from vibrations, a cloak of 100 concentric plastic and concrete rings is created, burying it at least 3 feet beneath the foundation of the building. As seismic waves enter the rings, ease of travel forces them to move towards the outer ring. This way, they are essentially channeled away from the building and dissipated into the ground.
Lastly, to reinforce the building structure, for it to withstand collapse, buildings must redistribute forces that travel through them during a seismic event. When building a structure, engineers must also take into consideration the materials being used. One earthquake-proof material that we suggest is structural steel. Structural steel is a component that comes in a wide range of shapes and allows buildings to bend without breaking. Additionally, it is also a material that resists stress and vibration. It has high ductility, which is the ability to undergo large deformations and tension.
Thank you for listening to our presentation, and I hope that you have a great day ahead.